Open Stax Psychology Chapter 5 Sensations and Perception Introduction. Imagine standing on a city street corner. You might be struck by movement everywhere as cars and people go about their business, by the sound of a street musician melody of a horn honking in the distance, by the smell of exhaust fumes or of food sold by a nearby vendor, and by the sensation of hard pavement under your feet. We rely on our sensory systems to provide important information about our surroundings. We use this information to successfully navigate and interact with our environments so that we can find nourishment, seek shelter, maintain social relationship, and avoid potential dangerous situations. This chapter will provide an overview of how sensory information is received and processed by the nervous system and how that affects our conscious experience of the world. We begin by learning that distinctions between sensations and perception. Then we consider the physical properties of light and sound stimuli, along with an overview of the basic structure and function of the major sensory systems. The chapter will close with a discussion of a historically important theory of perception called Gestalt. Section 5.1 Sensation versus Perception. Sensation. What does it mean to sense something? Sensory receptors are specialized neurons that respond to specific types of stimuli. When sensory information is detected by a sensory receptor, sensation has occurred. For example, light that enters the eye causes chemical changes in cells that line the back of the eye. These cells relay messages in the form of action potential, as you learned when studying biopsychology, to the central nervous system. The conversion from sensory stimulus energy to action potential is known as transduction. You have probably known since elementary school that we have 5 senses: vision, hearing, smell, taste, and touch. It turns out that this notion of 5 senses is oversimplified. We also have sensory systems that provide information about balance, body position and movement, pain, and temperature. The sensitivity of a given sensory system to the relevant stimuli can be expressed as an absolute threshold. Absolute threshold refers to the minimum amount of stimulus energy that must be present to the stimulus to be detected 50% of the time. Another way to think about this is by asking how dim can a light be, or how soft can a sound be and still be detected half of the time. The sensitivity of our sensory receptors can be quite amazing. It has been estimated that on a clear night, the most sensitive sensory cells in the back of the eye can detect a candle flame 30 miles away. Under quiet conditions, the hair cells can detect the tick of a clock 20 feet away. It is also possible for us to get messages that are presented below the threshold for conscious awareness. These are called subliminal messages. A stimulus reaches a psychological threshold when it is strong enough to excite sensory receptors and send nerve impulses to the brain. This is an absolute threshold. A message below that threshold is said to be the subliminal. We receive it, but we are not consciously aware of it. Over the year, there has been a great deal of speculation about the use of subliminal messages in advertising rock music and self-help audio programs. Research evidence shows that in a laboratory setting, people can process and respond to information outside of awareness, but this does not mean that we obey these messages like zombies. In fact, hidden messages have little effect on behavior outside of the laboratory. Absolute thresholds are generally measured under incredibly controlled conditions in situations that are optimal for sensitivity. Sometimes We are more interested in how much difference in stimuli is required to detect a difference between them. This is known as the just noticeable differences, or difference threshold. Unlike the absolute threshold, the difference threshold changes depending on the stimulus intensity. As an example, imagine yourself in a very dark movie theater. If an audience member were to receive a text message on her cell phone, which caused her screen to light up, chances are that many people would notice the change in illumination in the theater. However, if the same thing happened in a brightly lit arena during a basketball game, very few people would notice. The cell phone brightness does not change, but its ability to be detected as a change in illumination varies dramatically between the two contexts. Ernest Weber proposed this theory to change in difference thresholds in the 1830s, and it has become known as Weber's law. The difference threshold is a constant fraction of the original stimulus, as the examples illustrated. Perception. While our sensory receptors are constantly collecting information from the environment, it is ultimately how we interpret the information that affects how we interact with the world. Perception refers to the way sensory information is organized, interrupted, and consciously experienced. Perception involves both bottom-up and top-down processing. Bottom-up processing refers to the fact that perceptions are built from sensory input. On the other hand, how we interpret those sensations is influenced by our available knowledge, our experience, and our thoughts. That is called top-down processing. One way to think of this conception is that sensation is a physical process, whereas perception is psychological. For example, upon walking into a kitchen and smelling the scent of baking cinnamon rolls, the sensation is the scent receptors detecting the odor of the cinnamon, but the perception may be, this smells like the bread Grandma used to bake when the family gathered for holidays. Although our perceptions are built from sensations, not all sensations result in perception. In fact, we often don't receive stimuli that remains relatively constant over prolonged periods of time. This is known as sensory adaptation. Imagine entering a classroom with an old analog clock. Upon first entering the room, you can hear the ticking clock. As you begin to engage in conversation with classmates or listen to your professor greet the class, you are no longer aware of the ticking. The clock is still ticking, and that information is still affecting sensory receptors of the auditory system. The fact that you no longer perceive the sound demonstrates sensory adaptations and shows that while closely associated, sensations and perceptions are different. There is another factor that affects sensation and perception: attention. Attention plays a significant role in determining what is sensed versus what is perceived. Imagine you are at a party full of music, chatter, and laughter. You get involved in an interesting conversation with a friend, and you tune out all the background noise. If someone interrupted you to ask what song had just finished playing, you would probably be unable to answer the question. One of the most interesting demonstrations of how important attention is in determining our perception of the environment occurred in a famous study conducted by Daniel Simmons and Christopher Chabris. In his study, participants watched a video of people dressed in black and white playing basketball. Participants were asked to count the number of times the team in white passed the ball. During the video, a person dressed in a black gorilla costume walks among the two teams. You would think that someone would notice the gorilla, right? Nearly half of the people who watched the video didn't notice the gorilla at all, despite the fact that he was clearly visible for 9 seconds. Because participants were so focused on the number of times the white team was passing the ball, they completely tuned out other visual information. Failure to notice something that is completely visible because of a lack of attention is called inattentional blindness. In a similar experiment, researchers tested inattentional blindness by asking participants to observe images moving across a computer screen. They were introduced to focus on either white or black objects, disregarding the other colors. When a red cross passed across the screen, about 1/3 of subjects did not notice it. Motivation can also affect perception. Have you ever been expecting a really important phone call, and while taking a shower you think you hear the phone ring, only to discover that it is not? If so, then you have experienced how motivation to detect a meaningful stimulus can shift our ability to discriminate between a true sensory stimulus and a background noise. The ability to identify a stimulus when it is embedded in a distracting background is called signal detection theory. This might also explain why a mother is awakened by a quiet murmur from her baby, but not by other sounds that occur while she is sleeping. Signal detection theory has practical applications, such as increasing air traffic controller accuracy. Controllers need to be able to detect planes among many signals that appear on the radar screen and follow those planes as they move through the sky. In fact, the original work of the researcher who developed signal detection theory was focused on improving the sensitivity of air traffic controller to the plane blips. Our perception can also be affected by our beliefs, values, prejudice, expectations, and life experiences. As you will see later in this chapter, individuals who are deprived of the experience of binocular vision during critical periods of development have trouble perceiving depth. The shared experiences of people within a given cultural context can have pronounced effects on perception. For example, Marshall Siegel, Donald Campbell, and Melville Herskovits published the results of a multinational study in which they demonstrated that individuals from Western cultures were more prone to experience certain types of visual illusions than individuals from non-Western cultures, and vice versa. One such illusion that Westerners were more likely to experience was the Mueller-Lyer illusion. The lines appear to be different lengths, but they are actually the same length. These perceptual differences were consistent from differences in the types of environment features experienced on a regular basis by people in a given cultural context. People in Western culture, for example, have perceptual context of buildings with straight lines, what Siegel's study called a carpented world. In contrast, people from certain non-Western cultures with an uncarpentered view, such as Zulu of South Africa, whose villages are made up of round huts arranged in circles, are less susceptible to this illusion. It is not just vision that is affected by cultural factors. Indeed, research has demonstrated that the ability to identify an odor and rates its pleasantness and its intensity varies cross-culturally. Children described as thrill seekers are more likely to show taste preference, for instance, sour flavors, which suggests that basic aspects of personality might affect perceptions. Furthermore, individuals who hold positive attitudes towards reduced fat foods are more likely to rate foods labeled as reduced fat as tasting better than people who have less positive attitudes about these products.